Okay, students, we will start the remaining topic of Lind's method. The molecules of the compressed gas are very close to each other, and appreciable attractive forces are present among them. When a gas is allowed to undergo sudden expansion through the nozzle of a jet, then the molecules move apart. In this way, energy is needed to overcome the intermolecular interactions. This energy is taken from the gas itself and which is cooled. Lind's method of liquefaction of gases. Lind has employed Joule-Thomson effect as basis for liquefaction. The apparatus designed for this purpose is shown in fig in textbook. For the here, this is the fig for the liquefaction of gases. For the liquefaction of air, it is compressed to about 200 atmosphere and then pass through a water-cooled pipe where the heat of compression is removed. It is then allowed to pass through a spiral pipe having a jet at the end. When the air comes out of the jet, the expansion takes place from 200 atmosphere to 1 atmosphere. In this way, considerable fall of temperature occurs. This cooled air goes up and cools the incoming compressed air. It returns to the compression pump. This process is repeated again and again. The liquid air is collected at the bottom of the expansion chamber. All gases except hydrogen and helium can be liquefied by the above procedure. And this was method of liquefaction of gases. Now we will start the last topic of the chapter gases is plasma state. Plasma state. Plasma is often called the fourth state of matter. It is also called fourth state of matter. The other three being solid, liquid and gas, and it is fourth state. Plasma was identified by the English scientist William Crookes in 1879. In addition to being important in many aspects of our daily life, plasmas are estimated to constitute more than 99% of the visible universe. Although naturally occurring plasma is rare on Earth, there are many man-made examples. Inventors have used plasma to conduct electricity in neon signs and fluorescent bulbs. Scientists have constructed special chambers to experiment with plasma in laboratories. It occurs only in lightning discharges and in artificial devices like fluorescent lights. How is plasma formed? Plasma, ionized gas mixture consisting of ions, electrons and neutral atom is called plasma, and these ions are formed by the ionization process. When more heat is applied, atoms or molecules may be ionized. An electron may gain enough energy to escape its atoms. This atom loses one electron and develops a net positive charge. It becomes an ion. In a sufficiently heated gas, ionization happens many times, creating clouds of free electrons and ions. However, all the atoms are not necessarily ionized, and some of them may remain completely intact with no net charge. The ionized gas mixture consisting of ions, electrons, and neutral atom is called plasma. It means that a plasma is a distinct state of matter containing a significant number of electrically charged particles, a number sufficient to affect its electrical properties and behavior. Now we will move towards the next topic of plasma, natural and artificial plasma. There are two types of plasma, natural and artificial. Artificial plasma can be created by ionization of gas, as in neon science, and plasma at low temperature is hard to maintain because outside a vacuum, low temperature plasma reacts rapidly with any molecule of its encounters. This aspect makes this material both very useful and hard to use. And next is characteristics of plasma. Students, you must know the characteristics of plasma. Plasma may have sufficient number of charged particles, so as a whole it exhibits collective response to electric and magnetic fields. The motion of particles in the plasma generate fields and electric currents from within plasma density. And where is plasma found? Plasma is the most abundant form of matter in the universe. It is stuff of stars, and a majority of the matter in stellar space is plasma. All the stars that shine are all plasma. The sun is a 1.5 million kilometer ball of plasma heated by nuclear fusion. And now we will discuss the applications of plasma. A fluorescent light bulb is not like regular light bulbs. Inside the long tube is a gas. When the light is turned on, electricity flows through the tube. This electricity acts as a special energy and charges up the gas. This charging and exciting of the atoms creates a glowing plasma inside the bulb. Number second, neon signs are glass tubes filled with the glass. When they are turned on, then the electricity flows through the tube. The electricity charges the gas, possibly neon, and creates a plasma inside the tube. The plasma glows with a special color depending on what kind of gas is inside. Number third, they find applications such as plasma processing of semiconductors, sterilization of some medical products, lamps, lasers, diamonds, diamond coated films, high power microwave sources, and pulse power switches. They also provide the foundation. They also find the foundation for important potential applications, such as the generation of electrical energy from fusion, pollution control, and removal of further chemicals. Plasma light up our offices, home, make our computers and electronic equipment work. They drive lasers and particle accelerators, help to clean up the environment, pasteurize foods, and make tools corrosion resistance. Okay, thank you.